Hello everyone, in today's video, we are going to talk more on exponential and logarithmic functions. So we are going to solve exponential and logarithmic equations. These are the things that you should learn from this video. First, solve simple exponential and logarithmic equations. Second, solve more complicated exponential equations. Third, solve more complicated logarithmic equations. And fourth, use exponential and logarithmic equations to model and solve real-life problems. So as an introduction, there are two basic strategies for solving exponential or logarithmic equations. The first is based on the one-to-one properties, and the second is based on the inverse properties. For a greater than 0 and a is not equal to 1, the following properties are true for all x and y for which log x to the base a and log y to the base a are defined. One-to-one properties, meaning if we have a raised to x equals a raised to y, if and only if x equals y. Then we also have log x to the base a equals log y to the base a, if and only if x equals y. For the inverse properties, we have a raised to log x to the base a equals x. And then we have log a to the x to the base a equals x. So we have one-to-one properties and inverse properties. Now let us have some equations that we can rewrite and we can use the properties, okay? So the first one is the one-to-one properties. So let us have these examples. First, we have 2 to the x equals 32. We can rewrite it as 2 to the x equals 2 to the fifth because 2 to the fifth equals 32. So from here, x equals 5. The property is 1 to 1. We have log x to the base 4 minus log a to the base 4 equals 0. We can transpose minus log a to the base 4. So we will be having log x to the base 4 equals log a to the base 4. Then we have the solution x equals 8 and is still under one-to-one property. Then we also have ln x minus ln 3 equals 0. In here, we can transpose. So ln x equals ln 3. The solution is x equals 3. So still we have in under one-to-one property. And the last one, 1/3 raised to x equals 9. For the rewritten equation, we have 3 to the negative x equals 3 squared. From here, the solution is x equals negative 2. Is still under one-to-one property. Now let us have under inverse property. So e to the x equals 7. It is rewritten as ln e to the x equals ln 7. So the solution x equals ln 7. And then ln x equals negative 3. We are going to have e raised to ln x equals e raised to negative 3. So the solution, x equals e raised to negative 3. Then we also have log x to the base 10 equals negative 1. So we can rewrite it as 10 raised to log x to the base 10 equals 10 to the negative 1. For the solution, x equals 10 to the negative 1, which is also equal to 1 over 10. And for the last one, under inverse property, log x to the base 3 equals 4 can be rewritten as 3 raised to log x to the base 3, which is equal to 3 to the fourth. And from here, x equals 81. The strategies used are summarized as follows. First, rewrite the original equation in a form that allows the use of the one-to-one properties of exponential or logarithmic functions. The second one, rewrite an exponential equation in logarithmic form and apply the inverse property of logarithmic functions. The third one, rewrite a logarithmic equation in exponential form and apply the inverse property of exponential functions. Now, to solve a logarithmic equation, you can write it in exponential form. So if we have ln x equals 3, we have to exponentiate each side. So we have e raised to ln x equals e to the third. And then we have the exponential form x equals e to the third. This procedure is called exponentiating each side of an equation. It is applied after the logarithmic expression has been isolated. Now let us solve each logarithmic equation. If we have ln 3x equals 2, to solve for this one, first write the original equation and then exponentiate each side. And then we have the inverse property. So we have 3x equals e to the second. And then we are going to multiply each side by 1/3. So x equals 1/3 e is squared or e to the second. And then using the calculator, x is approximately equal to 2.46. So the solution is x equals 1/3 e to the second or e squared. To check whether your answer is correct, all you need to do is substitute the value for your x in the original equation. Now, let us have log 5x minus 1 to the base 3 equals log x plus 7 to the base 3. So the first thing we need to do here is to write the original equation. And then, using the one-to-one property, 5x minus 1 equals x plus 7. Then solving for x, x equals 2. The solution, x equals 2, you can check this one using the original equation. You just need to substitute x equals 2 to the original equation. Now let us prove the change of base formula. So log x to the base a equals log x to the base b over log a to the base b. So to begin with, let y equals log x to the base a. And then write the equivalent exponential form. So we have a to the y equals x. From here, we are going to take the logarithms with base b of each side produces the following. So log a raised to y to the base b equals log x to the base b. From here, we are going to use the power property. So it is equivalent to y log a to the base b equals log x to the base b. From here, we are going to divide each side by log a to the base b. And then we are going to replace with log x to the base a. So we have log x to the base a equals log x to the base b over log a to the base b. So let us have a real-life application entitled Doubling an Investment, meaning you are going to double your investment. So you have deposited $500 in an account that pays 6.75% interest, compounded continuously. How long will it take your money to double? For the solution, using the formula for continuous compounding, you can find that the balance in the account is A equals PE raised to RT. So we are going to substitute all the values. Your P is equal to 500 and your rate will be converted to decimal. So 6.75% is equal to 0.0675. And then since we are looking for the time, so T. So 500 e raised to 0.0675 t. From here, To find the time required for the balance to double, let A equals 1,000 and solve the resulting equation for T. Since we are going to double it, we already have initially $500. So if we are going to double it times 2, so A should be equal to 1,000. So that is why A equals 1,000. Now, we are going to substitute 1,000 for A. So we will be getting 500 e raised to 0.0675t equals 1,000. And then we are going to divide each side by 500. So we will be getting e raised to 0.0675t equals 2. From here, we are going to take the natural logarithm of each side. So we have ln e raised to 0.0675t equals ln 2. And then we are going to have the inverse property and dividing each side by 0.0675. So we will be getting t is equal to ln 2 over 0.0675. Using the calculator, t is approximately equal to 10.27. So the balance in the account will double after approximately 10.27 years. So that's it for now. Thank you for watching. See you again next time. Bye.